Hello, welcome to Kyiv, Ukraine. It's a pleasure to see you all here. My name is Nikolsko-Rzhevskyy from Lehigh University, and I will be the chair of the first session. Before we proceed with the session itself, I would like to thank the organizers for organizing this wonderful conference, and of course to thank the sponsors to make this conference happen. The name of the first session is Central Bank's Response to Slow Economic Growth. And before we start, a couple of words about the format of the presentations. So we have 3 speakers and 2 hours for the presentation. Therefore, each presentation will last about 40 minutes, which will be split into this 30-minute presentation and a 10-minute Q&A session. Of course, if you happen to have a short question which could be answered in a couple of words, please feel free to raise your hand and ask it. And if your question is more substantial, I would appreciate if you can hold it until the presentation is over so that you can ask it during the Q&A session. And our first presenter is Gianluca Benigno from London School of Economics, and he will talk about stagnation traps. Please.
Okay, thanks. It's a pleasure to be here. Thank you for inviting me. This is joint work with Luca Fornaro. And as the title suggests, it's inspired by the recent debate on secular stagnation. And the question we try to address in this paper is to try to understand to what extent it is possible to explain a period of long stagnation through an aggregate demand channel. And this debate on secular stagnation is a debate that has gained traction since the famous speech by Larry Summers a few years ago at a research conference at the IMF. And it has gained traction because of what advanced economy have experienced in the past few years following the global financial crisis. The term secular stagnation is not new. It was first coined after the Great Depression. But as I said, the Japanese experience since the mid-90s and the slow recoveries of the advanced economy after the global financial crisis have put forward again the attention towards the so-called secular stagnation hypothesis. Now, what I want to emphasize here is that most of these economies, the Japanese economies or the advanced economy following in the aftermath of the global financial crisis, have experienced some key characteristics in their economic development. So first of all, those economies have experienced long-lasting slumps. And these slumps have lasted long despite the fact that policy rates have been set at a lower bound. And also, interestingly enough, there have been revision to potential growth, downward revision to potential growth. And also effective growth have been lower than in the pre-financial crisis period. Now, as an example, I'm going to take the Japanese economy. And this is the behavior of the policy rate for the BOJ. We see that there is some variability up and down until the crisis in the mid-90s. And since then, I mean, there's been a sharp decline. And since then, the policy rate has been basically at a lower bound. Okay. What is interesting here in this graph is also, if you look at it, there is something interesting, is the fact that it looks like this economy, the Japanese economy, goes from one regime to another regime, okay? From a regime in which interest rates are relatively high and variable to a regime in which interest rates are stuck at a lower bound. Something similar occurs for the unemployment figure. So this is the behavior of unemployment rate for the Japanese economy. It's a very low level, but again, you see a similar pattern. A pattern from which you go from one relatively low unemployment rate to a relatively high one, almost double. It's still very low compared, for example, to European standard, but the fact is that it looks like the economy moved to a different regime. This is another graph that captures our proxy for productivity. There is more volatility here in this series, but again, you see that there is relatively high productivity, and then after the crisis, relatively low productivity. And finally, this is the behavior for the log of GDP in real terms for the Japanese economy. Again, what is interesting is that there is a substantial deviation from the trend after the crisis. Now, something similar, I don't have the graphs here with me, but of course there are some differences, but something similar you can plot for the US economy, the European economy, and also for the UK economy, despite the fact that both UK and US have actually recovered in terms of unemployment. But to summarize all this, we have this table here in which we collect the averages for different variables here, the policy rate, the real rate, the unemployment rate, and labor productivity growth, pre-crisis and post-crisis for Japan, United States, and the euro area. And again, there is this systematic pattern in which you go from relatively high to a much lower rate. For basically, this pattern is common among all these economies. Now, how can we explain this? How can we address this? And this is the challenge that we try to study here in this paper. And what we do here, and we propose a framework to interpret these facts. And the framework that we propose is what we label as a Keynesian growth framework. And what does it mean, Keynesian growth framework? Keynesian growth framework is a framework in which basically what we try to understand, and we try to understand growth through a theory of a short-run fluctuation. And the theory of short-run fluctuation that we adopt is a Keynesian theory. It's a theory based on Keynesian friction. So what we have here, we have a model in which growth is endogenous. At the same time, what happens in the long run can be affected by the cyclical behavior of the economy. And the cyclical behavior of the economy is determined by Keynesian friction. Now, what is important here is that most of the time, when we look at general equilibrium model that widely used in central banking, we always look at models in which we think about the economy as the economy that stabilizes around a trend or around something that we cannot affect, okay? And basically, we always look at stabilization problem, something, the only thing that we care are basically second moments. But in this approach here that we suggest, what matters also are first moment. So this trend. And the trend can be affected by the cycle, basically, okay, endogenously. Now, in this framework, as I said, there are Keynesian frictions. And the Keynesian frictions that we consider are the presence of nominal wage rigidity and the existence of a zero lower bound on the policy rate. And basically, in this environment, we're going to have a situation in which aggregate demand is going to be short or weak because of unemployment when monetary policy is constrained at the zero lower bound. See, this is from the Keynesian side. And so this is our theory of fluctuation. And on the growth side, we are going to have endogenous growth in the sense that growth is going to be the outcome of investment choices conducted by profit maximizing firms. So what happens in this environment is quite interesting. There is an interesting interaction between aggregate demand and growth. So demand and supply, basically. On one end, weak aggregate demand has a negative impact on firms' profit, and firms will invest less. And when they invest less in innovation, that will result in low growth. Okay? On the other hand, low growth will reduce income of agents and will depress aggregate demand, especially when the economy is constrained at the zero lower bound. So what is the outcome of this interaction between Keynes and Schumpeter? The interaction is that what we can observe persistent or permanent slumps characterized by high unemployment and low growth. In particular, in our framework, there is a possibility that there are two equilibria. One equilibrium in which the economy is at full employment with relatively high nominal rates and high growth, so the good regime. And then there is a possibility also that the economy end up in what we refer to as a stagnation trap, the combination of a growth trap and a liquidity trap, in which there is relatively high unemployment, low growth, and a zero lower bound that binds. So how do we choose which one of the two equilibria arise? Our theory here is very basic, is very simple. So everything is determined by expectation. So expectation can coordinate on one or the other equilibrium. Okay? So after describing the mechanism and the outcomes of the model, we also examine and study how policy can avoid this problem. And we study different policies, where we look at optimal monetary policy, but we also look at policy that subsidize innovation. And we show that it is possible to eliminate the bad equilibrium, so the stagnation trap, if this policy or subsidies to innovation are properly designed. What is important is that this policy or subsidy to innovation have to be sufficiently aggressive. So you might do the right policy in our model, and so go in the right direction, but then might not be sufficient to eliminate the bad equilibrium. So you need to be sufficiently aggressive. So that's the important aspect of the policy design. Now, I'm going to describe briefly the model, and then the outcomes of the model, showing the stagnation trap equilibrium and the intuition behind it, and then conclude with the policy analysis. So the model is a relatively simple model in the sense that what we did is that we adopt a model of endogenous growth that builds upon a Gianluca or Grossman-Helpan model of vertical innovation. So what happens in those models is that you improve upon the quality of the good. And what we did is that we augment this model by considering nominal rigidities, or nominal wage rigidity, and also the zero lower bound. It's a closed economy in which there are firms that produce goods and invest in research and innovation. There are households that supply labor and consume, and there is a central bank that sets monetary policy. Our model here, the one that I'm presenting, and it's also what we have in the paper, is a model in which there are no fundamental shocks. So there are no productivity shocks, no demand shocks. But we just look at outcomes that are determined by expectation, but you can add those shocks. Now, on the household side, we have a representative household that consume a final good and supply labor inelastically. But it is possible to have unemployment here because of the presence of wage rigidities. The budget constraint is quite standard in the sense that these households own the firms and have access to nominal bonds that pay the nominal interest rate high. WLT is the wage income. To summarize, the household behavior just need to remember the last equation, which is the Euler equation that determines the intertemporal path of consumption. Okay? So it's a standard optimization problem from a household perspective point of view. So then we have firms, and we have firms that produce the final good. Again, this is a standard problem. There's nothing puzzling about what we do here. We borrow a given with structure. We have a final good that is produced by combining labor and intermediate input. This intermediate input, what is important is that are associated with their own productivity, AJ, and this is what can be improved upon time. What happens in at this level is that the firm maximizes profits, and we have the demand of labor, which is the first equation here, and the demand of intermediate input. Then there is an higher layer here, which is the production of intermediate goods. And these intermediate goods is where the innovation occurs. So in this market, in each sector, we have a leader that is producing the highest quality good, and then there are competitors that are producing goods that are a lower quality. Okay? Each good is produced by using one unit on the final good, and the outcome of this problem here for the sector J is that there is a limit pricing problem, so that the firm that is a leader set the price in order to grab all the profits from being a leader in this market. And what is important in all this is to remember that the profits that the leader gets depends on LT, which is our proxy for aggregate demand. Okay? So this is what is important to remember. The profits are a function of aggregate demand, basically. Now, the last step that I need to describe on the real side is the research and innovation process. And research and innovation here occur by allowing entrepreneurs to innovate upon existing products. And the innovation step, gamma, is exogenous. So what happens is that the entrepreneur decides how much to invest in order to innovate. But investment doesn't guarantee success in innovation, and mu captures the probability that you are successful in improving the frontier. Okay? What is important is that this probability of being successful is a function of how much you invest. So the more you invest, the higher is the probability that you can become successful in improving the quality of the good. Now, what you do is that you want to invest because you want to become a leader in the market. And why you want to become a leader? You want to become a leader because you're going to get the profits out of that. So the value of the innovation comes from being the leader tomorrow, when you can be the leader, or in the future, as long as others don't enter in that market and grab the reins from being a leader. Okay? So here we have that the value of innovation is basically discounting the profits tomorrow and the value of the patent in the future that takes into account of the future profits. But again, what you need to remember is that the value of the innovation depends on profits that are a function of aggregate demand. Okay? Now, in the research and innovation, there is free entry. So we need to impose a free entry condition that will determine in which the cost of innovation is going to be equal to the expected return from innovation. And this will determine basically how much you're going to invest. Okay? Now, to conclude this part, I'm going to just recall here what is going to be productivity growth in our model. And productivity growth in our model is going to depend by this mu here, that is how much you're going to invest. So this mu is a function of how much you're going to invest, and how much, again, remember this, how much you're going to invest depends on aggregate demand, basically. Now, we're going to have the equilibrium conditions in this economy, and what I want you to remember here is that in this economy, there is a possibility of unemployment, as I will explain in a minute, and we're going to define unemployment as the situation in which LT is going to be less than 1. Otherwise, when it's 1, we have full employment. So I'm now going to describe the nominal side of the model. So far, basically what I did, I just described the real side, household, and the innovation and firm behavior. Now I'm going to focus on the nominal side. And the nominal side here is going to be very simple. I'm going to consider an environment in which wages are fixed, basically, or they grow by an exogenous amount, pi w. Okay? This is a very, it's a simplifying assumption. Later in the paper, we are allowing also for a more standard way through which wages adjust, but they're still at least sticky. Here they're fixed, or they vary exogenously. Okay? Now, from this assumption, we get also price inflation that is going to be a function of wage inflation and productivity growth that is endogenous. Finally, I'm going to describe the behavior of a policy authority here, the central bank. And since in this economy, I'm assuming that wages are basically fixed, the central bank will only stabilize output or employment around full employment. Okay? So this is our reaction function. It's not a standard Taylor rule, but it's something very similar to a Taylor rule in which we only care about output stabilization. And this is because of the simplifying assumption that we have made. But the important aspect of the policy behavior is that there is a lower bound on the policy rate. So you cannot go below 0 here in this case. So what happens is that you combine everything together. And you're going to have an aggregate demand block, which is the combination of the Euler equation and the Taylor rule, the stabilization rule. So this equation here. Then we're going to have a supply block, which is the growth equation that determines how much you're going to invest. And then we have the market clearing condition. It looks complicated at first, because of course I don't have that much time to explain everything carefully, but it's not that complicated, trust me. It's just an equilibrium system of 3 equations in 3 unknowns, in which we determine employment, the growth rate of the economy, and consumption. Okay? Now, we do that, and we look at first the non-stochastic steady state. And in the non-stochastic steady state, we're going to have 3 relationships. The aggregate demand relationship, the growth equation relationship, and the market clearing condition. Now, the aggregate demand relationship is a positive relationship between employment and the growth rate of the economy. This positive relationship comes from the fact that as employment increased, the central bank increased the nominal interest rate. Okay? And that is consistent with higher growth in this economy through the Euler equation. But there is a kink in this relationship that comes from the fact that at center point, the central bank cannot stabilize the economy because of the lower bound. The growth equation, on the other hand, is much simpler in the sense that, based on the intuition that I tried to convey earlier on, it describes the link between the growth rate of the economy and the employment level. The higher is the employment, the higher is aggregate demand, the higher are the incentive for firms to invest in innovation, and the higher is the growth rate of the economy. So I now plot this relationship in these graphs here. And the red line is the aggregate demand curve, which is positive, and then there is a kink at the zero lower bound. And the blue line is the growth equation. So what you see there is that these two lines intersect at 2 points. One point is the good equilibrium, this one here, at which we are at full employment, the growth rate is relatively high, and there is a positive nominal interest rate. Here, we are at a stagnation trap equilibrium, in which the economy is at a low employment with low growth at a zero lower bound. So this stagnation trap equilibrium is the outcome of a growth trap and the liquidity trap. Now, what I want to discuss is what is important in determining the existence of a stagnation trap equilibrium. And first, I want to emphasize the fact that this economy has a zero lower bound. So if this economy doesn't have a zero lower bound, then the aggregate demand line wouldn't have any kink. It will be always possible to stabilize the economy around a good equilibrium. So it is important that there is this zero lower bound in order to have the stagnation trap equilibrium. The second assumption that is important is the fact that we are allowing for endogenous growth. So if you have growth that is exogenously given, then the GG line would just be a flat line. It wouldn't be a line in which growth depends on how much we invest, and that how much we invest depends on aggregate demand. So it would be just flat. Again, we would have just one equilibrium. Now, as I said before, this equilibrium is determined, the selection is determined by expectation. And here we just want to provide the intuition of what happens in this economy. So suppose that agents expect, for some reason that is unrelated to the economic condition, that growth is going to be low, then this expectation of low future growth will imply a low income and low aggregate demand today, because of the intertemporal link that comes from the Euler equation. So I will anticipate to grow low in the future, and I reduce my current demand today. At the zero lower bound, the central bank is not able to lower the interest rate to sustain full employment. And when aggregate demand is low, firms' profits are going to be low, and that will result in weak investment in innovation. And when there is weak investment in innovation, we're going to have expectation of weak growth that are going to be verified. So this is the circle that will occur and will determine how the economy ends up in the stagnation trap equilibrium. Now, I don't have that much time, but here is a graph in which, for example, we show how the economy that is subject to a shock to expectation converge towards the stagnation trap equilibrium. So there is a transition here that can occur towards the stagnation steady state. And then we, in the paper, and also here in the slides, of course, but I don't have the time, we discussed different extension to the framework, allowing for a more standard Phillips curve, and the policy that, monetary policy that reacts to wage inflation. And also, we allow for precautionary savings to study also the possibility that steady state real interest rate can be negative. So I have to conclude, but I'm just going to use 2 slides. One is to explain what happens when you have subsidy to growth and subsidy to innovation. And I'm going to show you graphically. Basically, what you do is that you raise the GG line in such a way that you eliminate the stagnation trap equilibrium. This subsidy works through an aggregate demand channel, basically. That's the key point. But if they're not sufficiently high, you might still have the bad equilibrium there, so the stagnation trap. And finally, I'm just going to conclude here and summarize briefly what this work is about. So first of all, we propose a framework, which is a Keynesian growth framework, in which we combine features of endogenous growth with a theory of economic fluctuation based on Keynesian frictions. And we show how this framework could rationalize the possibility that the economy ends up in persistent or permanent growth and liquidity trap. In this debate on secular stagnation, usually there are 2 perspectives. One perspective is the supply side perspective, and the other perspective is a demand side perspective. Here, in this framework, we showed actually that disentangle the 2 is not obvious. And another way of saying that is that in this framework, the inverse of Saïd laws hold. So lack of demand creates its own lack of supply, so that there is a link between demand and supply. So that's what I conclude here.
Thank you, Gianluca, for an excellent presentation. Now we have about 5 minutes for questions. I can actually give you the microphone, I think. Okay.
Thank you, Dr. Benigno, for acknowledging with your scientific investigation. My name is Olga, and I'm a PhD student. And my doctoral theses are also concerned to the monetary policy modeling and building monetary policy rule for small open economies as Ukraine. And my question will be concerned to other aspect. You outlined that Keynesian framework are stated, if in very simple form, tell that consist the linkages in a long-term horizon, the linkages between the unemployment and inflation trend. But the monetarist refuses that thesis. My question are concerned to next. Which paradigm, monetarism or new Keynesian, as you have used, are tells to us more truth? Thank you very much. Or the Keynesian monetary framework are more suitable for developing economies, and monetarist paradigm are more suitable for small open economies as a Ukraine, or it's not necessary? Thank you very much.
Okay. Okay. So I think in this. So let me say something about this framework here. Actually, in this framework, I think we go a little bit beyond this distinction between new Keynesian and monetarist, as you described, in the sense that actually, if you think about it, at the zero lower bound, there are strong non-super neutrality, in the sense that at the zero lower bound, there is a possibility of this bad equilibrium, and there are significant costs associated with that are growth costs. So this is a little bit different from those two frameworks. But I think in general, it's important, even for economies that are small open economies or developing economy, to study aspects in which you combine the growth dimension with the policy dimension. I think there is a paper tomorrow that is addressing this, but not from a Keynesian perspective, but eventually try to merge the two would be interesting as well. So it depends a bit on the economic environment that you study, but I think it's important, and what I'm trying to convey here is that you shouldn't forget about growth even when you think about policy or stabilization policy.
Ivan Medvedsky, postgraduate of Finance Department of Kyiv National Economic University, named after Vadim Hetman. My question, what is the place and role of central bank in macroeconomic and macrofinancial stabilization of national economy in medium term and long term period of time? Thank you.
Okay. So here in this framework, we have a standard role of central bank in the sense that in this environment, the central bank only care about standard macroeconomic stabilization process. Now, what going back to the introductory speech that we heard before, I think it's important also to think in terms of the financial stability side. And for example, here in the framework that I presented, what is missing is to think about the cost of other costs that arise from being at a zero lower bound in terms of financial stability costs that might arise because bubbles might build in debt equilibrium. When you are at a zero lower bound. So there is that cost there as well that I think would be interesting to capture. So in general, I think that a central bank should care about macroeconomic stability or price stability, but also be concerned about financial stability, since financial stability might have also impact on the primary objective of price stability. So here, we don't capture this financial stability side, but I think it would be interesting to think about that as well.
Thank you. We have time for 2 more questions.
Thank you for your work, presentation, and this interesting model. And here, next question. A big economies such as Japan, US, Eurozone, they have frozen interest rates at lower rate. I guess it might be because money emission is more power instrument for influence on the market than changing interest rates. So is there any money emission factor in your model?
No. There's nothing like that. So we are silent on that aspect. So we just think of just characterize monetary policy in terms of this interest rate. Yeah.
And finally, the last question is checking.
My name is Lehigh. I am from the Institute for Economics and Forecasting, National Academy of Ukraine. It's very important for us to understand where we can get the economic growth for Ukraine. It's very important. And in your presentation, you presented the Keynesian model of economic growth based on monetary policy. But if we consider the Keynesian model for economic growth, it's not only based on monetary policy. What Keynes says, that monetary policy has a short-term impact. And when we're talking about the economic growth, it's a long-term issue. And you presented the case of Japan, and we see that actually Central Bank of Japan tried to stimulate the aggregate demand through lowering the policy rate. And we see there is no strong relation between the monetary policy and aggregate demand. So we see that through monetary policy, we can stimulate aggregate demand. But what also says Keynesian, that for economic growth is also important fiscal stimulus. And he also said that fiscal stimulus in long term has a more impact on economic growth than monetary policy. Do you agree from your presentation that monetary policy is not the only instrument for long-term economic growth?
Well, in the model, there are two problems. One I didn't have the time to discuss, but as long as there are limits to what monetary policy could do, then there is the possibility that you end up in this bad equilibrium. Now, in this bad equilibrium, as you pointed out, one way in which you can escape is, for example, by using fiscal policy, and that. Again, you're going to have very strong multiplier effects coming from that, because you can achieve, higher growth rates. So it is probably the best policy tool, fiscal policy. We haven't studied it yet, but I suspect that fiscal policy would, or properly designed fiscal policy, would be the right policy to use in order to undo that. This problem here, this bad equilibrium. Okay.
Thank you so much for an excellent presentation and great questions. Let's all send the speaker. And our next presenter is Yuriy Gorodnichenko from Berkeley. Yuriy, you have the stage.
Thanks very much for putting me on the program. Is it work? Okay. Thanks very much for putting me on the program. It's a great pleasure to be a part of this conference. I tried to be here last time, but my wife was very, very pregnant and I couldn't come. It's too bad, and I'm extremely happy to be here. This is joint work with Oli Cordion and Mauricio Valletta. And the question we have in this paper is very much related to what Gianluca just presented. Okay. Gianluca just presented. We want to understand why we have secular stagnation, where does it come from, what should we do about it. And to give you, Gianluca showed you time series for Japan. I'm going to show you time series for the US. We didn't agree on this ex ante, it just happened to be so, but I think it's an extremely useful, if I make this work. No, yeah, I don't make this work. Okay. Well, okay, I'll keep talking. So the idea is this. We have a big recession in the US. It was a very big contraction. And in a typical business cycle, we have some quick recovery to the potential. It didn't happen in the US for whatever reason. We don't know why. That's one of the bigger questions we have out there. And this figure here shows you the dynamics of log GDP in the US over time. It's normalized to be 0 in the first quarter of 2007. And then you see that after a big contraction, you don't have a very fast recovery. In fact, you kind of continue growing at a similar rate after the recession is over. Now, to put this into perspective and give you a sense of where this is coming from, I also plot here the red line, which is the growth rate, the dynamics of potential output calculated by the Congress Budget Office in 2007. Just before the start of the recession, this is what I thought is going to happen for the next 10, 15 years. Okay? Now, typically, as I said, in a typical recession, after the recession is over, the black line should converge to the red line. We don't see it in the data. Okay, so it was, one of the big puzzles out there. But then what you see further is that CBO, Conrad Budget Office, started to revise the estimate of its potential output down. And so the distance between the black line and the potential output line is shrinking, but it's not shrinking because the actual output is catching up. It's shrinking because the CBO started to revise the estimate down. You move further in time, you see that the CBO started to revise estimates even furthermore. 4 years after the start of the recession, you see that they think actual output is not going to grow very fast for a long time, and the level of output is going to be pretty low. Then you move forward more in time, and you see that this revision is even further down, and you keep moving in time, and eventually there is no output gap, and this is just because we should probably press Ctrl-L to make full screen. Alex. Yeah, can you? All right, wonderful. Yeah, this is how it should look like. You see a big recession, that's potential output, and then you start to see big revisions down. And so now the distance between potential output and actual output is very, very low. But that's not because we have a catch-up from actual output. It's because CBO over time learns that we have no prospect of catching up. This recession seems to have a very permanent effect on output, right? And so this led to this discussion of secular stagnation that Gianluca wanted to explain in his paper. He said, look, we have this very permanent decline. How come we can have a scene like this? And very prominent economists very often made this observation that, look, we're probably in a state of secular stagnation. A prominent proponent for this is Larry Summers, who said here, I'm more convinced of secular stagnation than ever before. Okay, so it seems like more and more people believe that we're in a state of very low output for a very long period of time. Now, what does it mean for central banking? Like, should they really worry about this, or maybe it's a normal state of affairs, which should get used to it? And the key questions for these discussions: how much slack do we have in the economy? Basically, the distance between actual output and potential output. For example, here, this is the distance between the purple line and the black line as perceived now by the Congress Budget Office. And the second important question is how persistent these deviations from trends are, right? So in the beginning, when you compare the red line and the black line, it seems like this deviation from the potential is extremely persistent. But then if you look at the distance between the purple line and the black line, it's actually not so big, right? And so that changes very strongly policy prescriptions. Very appropriately, we have John Taylor here in this audience. He came up with a very simple framework to analyze monetary policy. You basically set interest rates as a function of deviations of inflation from its target, and also deviations of output from its potential. So output is YT, potential is YT star. If this gap is very big, it means you have to tighten monetary policy because you overheat the economy. If this number is negative, it means you have to have expansionary monetary policy and stimulate the economy so that it catches up to the potential. Now, these revisions in the potential output in Y star suggest that the distance between the actual output and potential output is not very big anymore, and so we shouldn't really have expansionary monetary policy, right? But if you go back in time and look at what people thought in, say, 2009, 2010, there was a giant difference between the actual output in the US and actual output in the US. The magnitude was roughly $1 trillion. It was a lot of money. It was a very strong argument for a very expansionary, very aggressive monetary policy. When you look at the present situation, the case for this is much, 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 much weaker, right? Now, but before we jump to this conclusion, right, so there is this evolution in beliefs about what we should do about monetary policy. Should we stimulate output or not? Should we have expansionary monetary policy or not? We really have to understand why we have these big revisions in the potential output, right? Why did CBO did these huge changes? They basically said, well, before we thought we were behind roughly $1 trillion, now it's okay. What did change in the last 10 years, or 7 years, or 8 years, right? Unfortunately, we know very little about how people come up with these estimates and why they revise their estimates. what kind of properties we have for these estimates of potential output. And the purpose of this paper is to come up with some very simple statistical framework to understand basic properties of potential output. Like, do they respond to certain types of shocks? If they do, how? What's the difference between potential and actual output responses? And this can be very helpful for understanding the implications for monetary policy. How this distance between YT and YT star in the Taylor rule is moving in response to shocks. Okay. Now, what do we do in this paper, right? So the first part of the exercise is obviously to collect data to understand statistical properties of the series. And we do this for a number of countries, including the US and many other countries in the developed world. Then we come up with what we call structural shocks, something which has an interpretation, something that moves potential output, and we can say, okay, there is a causal relationship between the shock and responses of output. For example, you have a monetary policy shock, you stimulate the economy, we know causation is flowing from monetary policy to the reaction of output. And you can have other shocks like this. Now, once you do this, we find several striking results. One is that potential output is responding not only to supply-side shocks, but also demand-side shocks. Right? And for example, if you work in the framework of Gianluca and Luca Fornaro, then you can explain this. But in a typical framework, what you should see is that potential output should be responding only to the supply-side shocks. There should be no reaction to transitory cyclical shocks. In fact, potential output is often defined as something which is not responsive to the business cycle. And yet we find that, things which presumably generate the business cycle also move potential output quite a bit. Then also what we find, and we found it very interesting, is that the potential output eventually catches up with actual output, right? So for a while there is some difference, there is an output gap, so to say, but 2, 3, 4, 5 years out after the shock, there is basically no difference, and incentives for the central bank to respond to the shock are much, much weaker because the distance between the actual and potential output is so small. Probably the most striking result in our paper is that, we have very sophisticated models, it turns out, to calculate these estimates of the potential output. But in the end, we can have a very simple univariate statistical framework, which is called Hodrick-Prescott filter, which is going to summarize all the properties we care about for this potential output in a very, very simple way. And the downside of this approach, of this finding, is that, if this is really the case, then the main conclusion we get from here is that whatever declines in potential output we see now, they're not really permanent. This is just a statistical artifact. We had a period of suppressed growth. We calculate the moving average. This moving average is going to decline for a while, but then we can have a period of accelerated growth and we kind of go up in the opposite direction. Right? So whatever we see now, and we call it secular stagnation, is not necessarily secular stagnation. We just had a bad shock which lasted for a long period of time. That's it, nothing more. Now, what is the potential output? There are 3 main approaches out there. One is the production function, when you have a measure of output, Y, this is your left-hand side variable. Then you have a measure of capital, or capital services, K star. This is what you would have in normal set of circumstances. When you have a work week of capital, you say have 2 shifts, everybody's working normal hours, this kind of thing. Then you have a measure of labor input. Again, people work normal hours, you don't have a lot of overtime, you also don't have a lot of underemployment. And then you have a measure of productivity, and typically you have to make some assumptions about this because we don't see it directly. You plug in these 3 quantities into the production function, you have a measure of output. And it should be cyclically insensitive. The second approach is purely statistical. When you look at the time series and you say, well, this series is fluctuating around some trend, a slow-moving component, and we're going to call this slow-moving component trend a potential output. This is where we should be if we don't have big variations in the business cycles. Okay, there are some examples here, but it doesn't matter. Hodrick-Prescott is one of them. A more structural approach is to write down a very sophisticated model where you have all sorts of interactions between agents. You can estimate this model, you can estimate various frictions, various structural shocks, and then the way you construct a potential output, you say, suppose I can turn off some of these frictions. So for example, pretend I know people are fully rational and behave in a reasonable way. Or suppose I can get rid of price stickiness. Or suppose I can get rid of a ridiculous government. That will be my potential output. Now, this is a very sophisticated approach in the sense that, the data is actually not terribly informative to have something like this well identified, but at least it's, an internally consistent framework which may be very useful for counterfactual analysis. Now, so that's the first input for this analysis. The second input, as I said, we have to have measures of potential output to study statistical properties. And here we have several sources. One is the Congress Budget Office, which is, in a way, in the US, the gold standard of calculating these numbers. It uses the production function approach, and the time period for this estimate in real time starts in 91, and we have estimates through the present. Then we have projections from what is called green books. This is a macroeconomic forecast prepared by the staff of the Federal Reserve Board for members of OMC who are setting up monetary policy. They don't use a single method. They have actually a variety of methods, including the judgmental, which means, those people look at the data and try to use information which is not necessarily in the models to make sure that they have the best possible estimate. The sample for this source is very good between 87 and 2011. There is a 5-year delay. That's why we don't have present in the release of this information. But if we are willing to make more assumptions about, all sorts of sources and estimates coming from the government, then we can use an extended sample which starts in 1969, and you'll see what's important in a bit. Then we have the IMF, International Monetary Fund, which also uses a mix of methods, including the judgmental. The key advantage of this source is that, unlike the US, it has many, many countries, obviously, and we can utilize not only time series variation in the estimates of the potential output, but also cross-sectional variation. We can say compare Ukraine and Poland and see how potential output is moving in these countries over time or in a point in time. Then another source of international data is Organization for Economic Cooperation and Development, OECD. Similar to the CBO, it uses production function. It has even more countries than the IMF, and it has even longer time series. So there we have some of the longest time series and a lot of observations. This data set is going to be very informative for us. Now, all these first four sources give you sort of public estimates, in the sense they come from public institutions run by the government. We want to know what the private sector thinks. Unfortunately, private sector forecasters are not really interested in predicting potential output. They really want to know actual output, actual unemployment, actual inflation. And so here we have to make a certain compromise. We use consensus economics, which asks professional forecasters to predict what should be the growth rate of output in the next 5 to 10 years. And you would think that the business cycle should be done within 5 to 10 years, within 5 years. And so whatever happens between 5 and 10 years, this is all capturing long-term growth. Okay? So that's going to be our proxy of potential output growth rate. All right, so that's the second ingredient for our analysis. Let me skip this one. Now, let me give you a few very basic stylized facts before I tell you kind of a more formal analysis we're going to do. One is that we have this discussion about secular stagnation when we have consistently negative revisions in potential output. And it seems like whenever we have a revision, we always have a secular stagnation. We always go in a negative territory. But there are some very prominent counterexamples when revisions were also one-sided, but going in the opposite direction. For example, in the US, there was acceleration of economic growth in the late 90s, early 2000s. You see this black line, actual output, is growing very, very fast. And you see that, before this acceleration happened, CBO in 95, this is the red line, was projecting that output is going to grow, but not really fast. Then over time in 97, they said, well, maybe it's actually a little slower than we thought. But then later in 99, in 2003, 2001, they started to revise their estimates up because they see the economy is growing really, really fast. And they say, well, it's a new economy, it's the IT sector, it's very important. From now on, we're going to have a very high output growth rate. Productive capacity of the economy is expanding very fast. So one, I guess, message from this fact is that we shouldn't have this discourse about, potential output, secular stagnation, or just, one-sided event. You can have big revisions in other directions as well. The second fact is that there is a lot of consistency in the estimates of potential output across sources. This figure shows to you the kind of distribution of beliefs about the growth rate of potential output from the IMF, that's the vertical axis, and the growth rate of potential output from OECD. The correlation is like 0.99. There are a few strange cases, like Slovakia in 2009. I don't know why these estimates are so different, but they're more like an a set of outliers rather than sort of a part of the genuine robust pattern in the data. Okay, so it seems like there is a lot of consistency in how people calculate potential output across those different agencies. And so by focusing on one agency, we're actually not losing that much. We can just look at one source, and that's going to be a good approximation of what other people think about these issues. Now, this very high correlation is not coming just from my cross-section. Like, one country, Poland, has a very high growth rate of the potential, and then all sources will agree that Poland is going to have a high growth rate, and say Ukraine has a low growth rate. It's not true. You can also see a lot of consistency in the time series dimension. This is the growth rate of potential output in the US since '97, and you have a variety of sources here. The red line is IMF, the blue line is OECD, Consensus Economics, Congress Budget Office is the black line, and the green book is what is predicted by the Federal Reserve System. And you see that all these lines are moving together very, very closely, okay? There is a lot of consensus across sources that we had a lot of acceleration in the late 90s, then we had deceleration in 2011, and so on. And in between there were some big revisions. For example, for some reason, CBO thought we were going to have a slow growth rate of the potential output in 91, 92. That was another pair of years when we had a recession in the US. Now, this is a relatively short time series, and so if we want to study statistical properties, it's one of the big problems for you. If you have, say, one observation, you can't really talk about trends. If you have two observations, you can draw a line, but that's it. You have to have really a lot of statistical data to have confidence in your estimates. And so what we try to do is to kind of look at longer-term trends, at least in the US, and see how this evolved over time. This green line is shown to you the dynamics of the growth rate of potential output since 1970s, and you see there was a gradual slowdown in the growth rate of the potential output from the 70s to mid-90s. But the growth rate of potential output we see now, in the end of the sample, year 2010, is actually very similar to what we saw in 1990s, and nobody talked about secular stagnation and the end of the world and all those kind of things. At least I wasn't around, but I couldn't find anything. Also, there is a big acceleration in the growth rate of the potential output around 2000. And again, nobody was talking about, well, we're going to be there permanently and this is the new normal. But somehow the discussions now are very convincing in the sense that everybody has a consensus view that we have a secular stagnation and there is no coming back. This is a new steady state for us. Now, does this estimate of the potential output make sense? We think so, right? So for example, we take estimates of growth rate of total factor productivity, calculate the moving average, plot this line here, this is the blue line, and you see there is a lot of movement between the green line and the blue line. The distance between these two should be basically capturing factors such as accumulation of capital, accumulation, growth rate of population, this kind of things. But broadly, you see a lot of movement between these two series, which is telling us that this green series, this green book estimates of potential output, this is not junk. This is actually something very useful. Now, one thing you can also do, you can say, okay, suppose I'm an economist at the Federal Reserve Bank, and I want to make a projection for potential output, and I have limited resources, and I have real-time constraints, so I don't have a hindsight and say, well, in the future this will be the growth rate, or in the past this was the growth rate. I just see whatever is available to me to a certain point in time. And then you say, suppose I run a very simple statistical tool when I try to equate potential output with the trend in the data, and I'm going to plot this time series here as the red line. And you see in this figure that roughly after 1985 or something like this, the red line and the blue line, they're extremely highly correlated, extremely highly correlated. So what it's telling us is that this very sophisticated machinery used by the Federal Reserve Board may be very much reduced to a very simple univariate statistical method. But because this HP filter, it doesn't have any structure, it's just a statistical artifact, it doesn't tell you anything about permanency or transitory nature of kind of fluctuations in the series. It's a slow moving thing, but there is nothing about permanent effects or transitory effects in this time series. You can do a little worse if you just use a very simple 5-year moving average, the black line. Okay. Now, a very sophisticated econometric framework, given how few observations we have. This is going to be really simple. It's going to be a series of univariate regressions where on the left-hand side you have a measure of the growth rate of actual output or potential output. Potential output is the second equation, actual output is the first equation. Then you have a measure of structural shocks, this epsilon, something which drives business cycles or long-term growth. This is your epsilon. And then you have a very simple statistical tool called OLS. You run this regression, you get estimates of phi and psi, and then you're going to employ what is called impulse responses. Basically, this is the dynamic response of the economy to a shock. Maybe immediately there is no reaction, but eventually there will be some movement. Okay? What would be the shocks? What would be the epsilons? What would be our sources of variation on the right-hand side? It would be supply-side shocks, which presumably really should be moving potential output. For example, if we become more productive, potential output should be moving there. Okay, it may be tax shocks because it changes incentives of people to work, and for example, you have a big tax cut, people are going to start working more. It may be related to oil price shocks because supply of energy is limited, elasticity of substitution is low. This can influence our productive capacity in the short run. We will also look at transitory demand-side shocks, which we know drive potentially business cycle, but should have really no long-term effects on output. And so for us, it's going to be a test that, estimates of potential output actually should not be responding to things like this because they are not really about long-term growth. They're just business cycle forces. This is this dynamic response to a particular shock, a total factor productivity shock. The black line is the response of actual output. The shaded region, you don't see it here. It's very light. Well, there is a shaded region, at least somewhere. You see that the black line is increasing on impact at the time of the shock. For example, here you see, right? A big reaction immediately, and then it stays roughly permanently higher. The blue line is what happens with potential output, and here what's striking is that this thing is not moving immediately, even though these people should be adjusting their estimates of potential output at the time of the shock. But over time, this blue line, the dynamic response of potential output, is catching up to the black line. And so then, in the beginning, we have a measure of output gap. This is when this model will say we have to stimulate the economy. Oh, I'm sorry, we should decelerate the economy. And here we say, well, no, we shouldn't do this because now actual output is equal to the potential output. You can do the same things for other supply-side shocks. I don't have time to show this to you. Here is an example of a demand-side shock. Basically, unanticipated shock to government spending. We know it has an expansionary effect, but it's going to be short-lived. Okay, so you have some reaction in the beginning, and then you basically converge to zero very quickly. Potential output is not going anywhere, but then it starts to increase, which is really counterintuitive. It shouldn't be doing like this. I guess another very good example would be monetary policy shock. You have a monetary tightening, no reaction in the beginning, but then you have some contraction. And then what's striking here is that the potential output is also moving quite strongly eventually, and it shouldn't be doing this because we know monetary policy shocks are going to be there only for a very short period of time. They should not influence our productive capacity in the economy. Now, to give you a recap, this is what we have. What's striking is that we see a reaction to all shocks. We shouldn't see something like this. And one exercise we did in the paper, we tried to understand why this blue line, the potential output, is moving so sluggishly but significantly over time. And this is just one example of what you would get if you apply the NHP filter to actual data, this very simple univariate method, and then study properties of this filtered series to a structural shock. Okay. So here, this is the blue line I showed you before. In the beginning, productivity is not changing, even though it should have been somewhere here. And then gradually it builds over time. Potential output is responding to the shock. So that's the good thing. But this red line is doing exactly the same thing. In fact, it's very hard to tell the difference between the two series statistically. Okay, so we say that whatever estimates people use out there, it's just a statistical construct. It's not really structural. Some other examples. Let me focus on the monetary policy shock. Okay, I showed you before that potential output is responding to the monetary policy shocks. It shouldn't be doing this. If you use Hoderick-Prescott filter, this red line, you can basically reproduce whatever estimates of the potential output responses you see in the data. So to us, it signals that whatever interpretation people have now, that we have this permanent decline in potential output, is not really coming from a deep kind of notion of something having permanent effects on output. This is just a statistical construct. Now okay, so this is just what I said, that whatever we see now, this interpretation that we have a permanent decline in productivity, maybe just, a statistical fluke, right? It's not a real fact. It just, by construction, we have something like this. We do a similar exercise for cross-country data. It has very similar spirit. We have a slightly different set of shocks just because this identification is very challenging. But by and large, we find very similar results. Let me just focus on one figure. Labor productivity, big permanent effect. This is the response of actual output. The blue line is what happens with the potential. Very similar to what we saw in the US. It's kind of slow reaction and then gradual build up. And this pattern in the potential output, this blue line, can be almost perfectly reproduced by a very simple univariate filter. Okay, univariate filter. And you can do the same thing for other shocks and other sources, so it doesn't really matter. Now, what do we have in the end? What's the bottom line here? Well, we have this result that estimates of the potential GDP coming from public or private sources respond only gradually to shocks, even though we know that they should be responding on impact very strongly to supply-side shocks. Also, what we see is that, a very simple univariate method such as Horek-Prescott filter can basically reproduce all properties we see for the potential output, and we shouldn't see something like this. It should be much more sophisticated than that. We should have a differentiation between supply-side shocks and demand-side shocks. Now, the fact, as I said before, that we have something like this in the data is telling us that this sense of permanency we get about the Great Recession, secular stagnation, and so on, is not necessarily an established, robust fact. It may be just a statistical result. And if we wait another couple of years, maybe we'll have an acceleration and people will forget about the Great Recession, secular stagnation, and so on. Now, what's the way forward? Really briefly, there is a lot of value in using additional information. We have to really differentiate between supply-side shocks and demand-side shocks. These are some approaches, Blanchard-Qua, Kartner, but there are many others. You should also use private sources, not just one series. It seems like consensus economics has useful information. Also, one thing which we found a little undesirable in the current practice of calculating potential output estimates is so-called model averaging, when you have a variety of techniques and then you take an average. And typically one of these ingredients in model averaging is the Horek-Prescott filter. And so it seems like this model averaging is really excessive. And finally, people often laugh when you tell them we use judgmental forecasts or whatever adjustments to potential output because it doesn't have any statistical foundation. We actually found that if you use more judgmental sort of adjustment ad hoc factoring, you do better than what you would get from a more formal model. Thank you.
Thank you, Yuriy, for the excellent presentation. Now, as always, we have time for questions. Please, let's start with the gentleman in the fifth row.
Оскільки я знаю, що ви добре володієте українською мовою, для того, щоб не втратити зміст запитання, я задам його вам на українську.
As far as I know that you speak very good Ukrainian, I would like to ask a question in Ukrainian. You spoke about 70s, and you know that in the middle of 70s, economic growth of J7 dropped down and never recovered to the same very level as it was before. So at the same time, there was another trend that is not recovered up until now. So this is more than 40 years, the tendency of the income norm and decline. So for the same period, these countries used all possible tools like of central banking and other tools of other financial institutions. However, there was over-accumulation of productive capacities, and the dynamics of economical growth could is still not recovered. So, as of today, what do you think? Can the policy of the central bank influence these trends in order to change their directions back to where they were? So the question is really difficult because economic growth in G7 countries has a lot of different factors, and this is not excessive capacity. That I translated as overaccumulated capacity, excessive capacity. There are many other factors that contribute to this issue. Up to my mind, this paper is not about the monetary policy that could influence on the economic growth in the long run. However, I think that our distinguished speakers, they said from the very beginning that Ukrainian National Bank or the National Bank of Poland, they cannot control the situation. Their task is to control inflation, and the rest should be done by other participants.
Thank you. Larry Ball from Johns Hopkins University. I think your results are very interesting and persuasive. Essentially that if output goes up or down, measures of potential tend to follow afterwards. It seems there's an obvious policy implication. You shy away from it. There's a question of should monetary and fiscal policy be more expansionary and try to push output back towards the old trend. I think your slide says the data is not informative about that. It seems to me the natural interpretation of your results is that the data are informative, and the data say that just as the Great Recession pushed output down and then potential followed, that if we had an overheating of the economy that pushed output up, then potential would probably follow, and that therefore the policy point of view that says, well, say in the US, output is currently close to the CBO's estimate of the natural rate, so we should not try to push output any higher, that's very dangerous and unnecessarily prolongs stagnation, and essentially it seems like your results make a strong case for more expansionary policy. So would you accept being pushed in that direction?
Okay, thank you. Thanks for your question. I agree. One interpretation of our results is that, our sense of no slack in the economy now may be just a purely statistical result. If you compare the estimate of CBO from 2007, the red line I showed you in the beginning, and the actual output, it's still very, very wide. And there are some signals consistent with the sense that we have a lot of slack in the US economy. You look at employment to population ratio, it has not recovered to the pre-recession levels. Now, one thing I wanted to emphasize in our work was that there is a lot of sampling uncertainty in our estimates, and there is a range of alternative interpretations consistent with our results. One thing which we also found very striking is that we often literally calculate the distance between actual and potential output and build policy around that. But our interpretation is that this construct we have called potential output requires a very careful interpretation. It's not necessarily a true potential output out there. It's like something statistical we construct for ourselves. And this can backfire in a sense. We can react too much or too little. That would be our conclusion, I guess.
But Vladimir Vasilyevich, Erasmus University. I want to follow up on this. So do you see evidence that Fed actually acts on this almost myopic behavior of congressional, at least since the beginning of quantitative easing? So
I'm not a
refer to the Taylor rules.
Yeah, we should ask John Taylor. I think there is evidence that people respond to this. It's very clear. If you look at the 70s, there was a sense that output gap is really, really big, and monetary policy should not be contractionary at any cost. It should be expansionary, if anything. Larry can correct me. There are other instances, for example, in the late 1990s when output was growing really fast. there was a growing concern, at least among some policymakers and private markets, that will have acceleration of inflation. And Greenspan at the time said, look, we shouldn't do this because we believe that productive capacity was expanding very fast. There is no slack in the economy. We should not push on brakes. We should not raise interest rates. And that was, I guess, one of these wonderful moments when you look at the data, you make the right inference, and you actually improve policy.
We have time for one more question.
Oleg Korenok, Virginia Commonwealth University. So if I push you in the other direction compared to Professor Ball and say, isn't your paper saying that according to our definition of potential output, if our definition is that supply shocks do not affect the potential output, then what you're finding is that we don't have a good way to find it. So whatever estimates we produce are not actually estimates of the idea of potential output. Whatever estimates we produce, since they respond to demand shocks, it's not really, so whatever we're seeing, Green Book or any other estimates, they're not really estimates of potential output.
Yes, that's certainly one conclusion we have reached, that whatever estimate of potential we have out there, it's not necessarily potential output the way we think about potential output in our models. Thank you.
Thank you, Yuriy. And now I want to invite our last speaker for today. Our last speaker, I mean, not for today, excuse me, of course, for the first session until we have our coffee break. And our speaker is Marcin Kolasa from Narodowy Bank Polski and Warsaw School of Economics. He will talk about demographic transition and monetary policy in a small open economy. Please.
This works? Okay. So first of all, thank you very much for putting this paper into this program of this very interesting conference. I'm really very happy to be here in Kyiv. So this paper is joint work with two colleagues of mine from Narodowy Bank Polski, Marcin and Michał Brzoza-Brzezina, and it's about the impact of demography on the monetary policy. Now, when you think about demography, then monetary policy is probably not your first association, right? If you think about the consequences of demographic development, so usually people think that demography operates at a sort of low frequency. These are pretty much compared to like normal business cycles, pretty much predictable developments. So, since monetary policy usually deals with short and medium term horizon, then probably these two things should not really matter for each other. So actually this kind of optics certainly changed following the secular stagnation debate, right? So now we think that there could be some link, and there have been several theoretical developments that help us to understand this nexus better. But I think that what we are still missing is a sort of like quantitative evaluation of these kind of processes. So this is essentially how this paper is going to contribute to this debate. So the outline is really pretty standard. I will try to motivate this work a little bit. I will sketch out the model because actually our main results are based on a macroeconomic model. I will show you some simulation results from this model, and then you will see some conclusions or takeaways that come from this analysis. Like are born, right, every year, okay, and also a declining mortality risk. So people live longer and longer. And actually, these are the processes that you see essentially in all countries. And if you don't see in some of them, then you are going to see them pretty soon, right? Even in some developing worlds. Of course, the speed and timing can be very different across the economies, and actually Poland is quite an interesting case in this argument because by some measures we have the worst demographic situation in the whole EU, so this makes it like a kind of nice case study, but I guess like generally the implications actually are very similar, or at least qualitatively for many other economies. So let me show you a couple of slides of what kind of processes we have in mind. So this chart plots the total fertility rate defined in a standard way as the number of kids per woman. You know that the sort of like replacement rate is 2.1. So this is like the average number of kids per woman that you should see, so that the population is constant under constant mortality risk. So you see that this is in the EU already, like this fertility rate has been below this threshold for quite a couple of years. The situation has got worse, like at least till the year 2000. Then you had some rebound and further projection of subsequent growth, but you still see that the fertility rate is very low, right? In Poland, actually, the situation in like 1980s was not that bad, but then more or less close to the collapse of the communist regime, you've seen like a very dramatic decline in this rate, so that it fell well below what you see in the rest of the EU. And even though like the prospects are somewhat positive in that respect, then again, like coming back to the levels that you've seen like several decades ago doesn't seem to be very, very plausible. On the other hand, you see quite a big increase in life expectancy. So of course, like the life expectancy in the EU is larger than in Poland, larger for females than for men. But most importantly, actually, is that, you know, in the EU, there is the projections and also the history show like a steady increase in this indicator. In Poland, again, like during the late communist times, we had a kind of stagnation in these indicators, but then following the collapse of the communist regime, you see like quite a steady increase of life expectancy. So this, of course, translates into like a kind of very important behavior of one of indicators that I show you here, which is old age dependency ratio, which essentially is defined as the number of retirees per working age population. So you see here that actually, for now, not really much has been going on, but if you move, like extrapolate these trends further into the future, under constant retirement age, you can see that the changes are quite dramatically, right? So old age dependency ratio is projected to like more than double in the EU, and in Poland, actually, this growth is going to be much bigger. So of course, you know, this might have like many actually macroeconomic implications. So I'm listing a couple of them that immediately come to your mind. So of course, this has implications for economic growth because labor is actually quite an important input to production. Of course, pension system sustainability is like an obvious issue to worry about. The size and composition of fiscal expenditures, because older people have like different needs as regards public services, housing market as well. And actually, you know, you can probably continue this list for a bit longer, but one of the areas that aging might affect as well is monetary policy. And let me first like give you a kind of overview from what we know from the theoretical contributions and also from some common sense, I would say, about how demography might impact the monetary policy. So one is clearly the drop in the real rate of return on capital, or the natural real interest rate. So just to cut the long story short, it's just, you know, if you expect to live longer, you have to accumulate more assets for the time when you're retired. So the savings supply goes up, and this, like through like the standard macroeconomic mechanism, leads to the decrease in the real interest rate. Then if you're in an open economy, then of course you save not only in your like domestically, but also, you know, some of these savings can be exported abroad. So you may expect some adjustment in the external balances. I mean, like the current account or eventually the international investment position. You may expect some changes in the transmission of monetary policy and also other macroeconomic shocks, right? Because people in different age might have at least different propensity to consume or respond differently to changes in the macroeconomic environment. And actually, importantly, also from this paper's perspective, you might expect an increased probability of being faced with a zero lower bound constraint, so something that was one of the key ingredients in Gianluca's model. So essentially, if you have like a drop in the real interest rate, you keep the inflation target at the same level, then the distance from the nominal interest rates in normal times to the zero lower bound gets smaller. So, you know, the risk of hitting it clearly increases. There are also like a couple of interesting papers that deal with social preferences towards stabilizing inflation. So this might also, like demography, might actually affect these processes. So what this paper is about, so as I sort of signaled, we try to deal with the quantitative impact of aging, so our focus will be the natural interest rate, but also these external balances. We'll have an open economy setting, so we'll be able to investigate the impact of foreign demography for a country like Poland or any small open economy that is quite strongly integrated with the rest of the world. What is especially, I think, important in this paper, we'll highlight the importance of observing the natural interest rate in real time by the central bank. This will be maybe some surprising outcome from our analysis, because, as I said, demographic processes are slow-moving processes, so you might tend to think that maybe it's not really so important to track these developments in real time. But I will show that, at least according to our results, it may matter quite a lot. And then I'll show you some quantitative implications for the probability of hitting the zero lower bound. So just the preview of the main findings in case I just run out of time. So we find with our model that actually the impact of aging on the rate of return on capital, or the natural rate of interest, can be actually quite substantial. So it's 1 percentage point for the euro area. Well, spread over 3 decades, but still quite a substantial shift. In Poland, even more actually. So it's nearly 2 percentage points. And actually, as I sort of signaled, we find it quite important to account for the fall in the natural interest rate in real time. So if you fail to do that, if you learn it gradually over time, you may end up in a quite serious downward bias in the inflation rate. And this bias, as I said, is quantitatively quite important. We estimate it even to go in as high as 1 percentage point at some points. As far as the implications for the zero lower bound, of course, it very much depends what's the standard value for the natural interest rate for the economy. For Poland is quite high, so that even if you see this decline of the natural rate of interest rate by nearly 2%, then actually the increase in this risk is not such great. But actually, if you fail to observe it in real time, it might become actually quite important. And then another, I think, quite important outcome is that even if you're a small economy, a small open economy, which is really highly dependent on what's going on abroad, then actually domestic demography is key for the rate of for the natural interest rate. So it's not that, at least you will see the mechanism, I hope, pretty soon. So let me skip the literature, just jump to the model, just starting with some overview. So the core of the model is something used widely in many central banks. So this is the new Keynesian setup, but a small open economy extension. But the main extension that allows us to investigate these issues that we are interested in is that we add some life cycle features to the model. So we have not one representative households, but actually 80 cohorts of overlapping generations of households. So people enter the model at the age of 20, and then they live the maximum number to the maximum number of years of 99. Of course, they can die until before actually reaching this age. So we have mortality risk that is age and time dependent. Okay, and we also account this rich structure allows us to account for age-specific productivity. So this actually quite matters for the results. In any model of this type, we have standard rigidities, and actually sticky prices are important here. We have also investment adjustment costs, very much tailor monetary policy rule, and then the model will be driven by the following exogenous processes. So we'll treat demographic processes as deterministic, because I think it's a reasonable way of thinking about that one. So the growth rate of initially young people and the mortality risk will be known to people, both in our economy that we study, but also in the euro area, which is mimics the rest of the world for Poland. But we also have like a bunch of stochastic shocks which we use to simulate the economy stochastically to evaluate the probability of hitting the zero lower bound, and this will be like a pretty standard shocks in this medium-sized new Keynesian model. So we'll have shifts in productivity, shifts in time preferences, monetary policy will be the source of shocks as well. We'll have the international risk premium shocks, which are important for open economies, and then foreign shocks will affect the Polish economy as well. I want to go pretty quickly through the equations, but at least I'm still going to show you a couple of them. So households are, live like for a couple of years, for the maximum number of years equal to the uppercase J. They discount the future utility flows, but the discounting is using the standard discount factor, but also this term, which is this n over the other n, which is essentially the probability of actually reaching a certain age. So this is what I mean by capturing this effect of mortality risks. So there is, for each household, there is a certain probability that he or she will not survive to the next period. Otherwise, the utility is pretty standard. We have the preference shock, but households care about consumption in a positive way and then dislike labor effort. The budget constraint is pretty standard, so households consume, but households also get labor income with age-specific productivity. This ZJ that you see in the budget constraint is the age-specific productivity, and they accumulate assets, okay? And also get some bequests from those guys that leave this world before the age of 99. So to keep the structure of this model simple and avoid some portfolio choices for each generation, we introduce into the model a special types of agents that we call investment funds, who essentially collect all the assets from households and manage them. And what management means is that they use it to purchase physical capital, they use it to purchase bonds denominated in the home currency and traded only internally, but they also trade in foreign currency denominated bonds, and they have also some access to equity. This is essentially allows them to draw profits from intermediate goods producing firms that are monopolistically competitive. So these investment funds maximize the expected gross return. So they get the return because they rent capital services to firms. They get each bond is pays the risk-free interest rate. Foreign bonds also pay a interest rate denominated in the foreign currency, and also there are some dividend flows that actually make up this return. Now, an important component is this gamma stuff that you see in this last line, which introduces some imperfection in international financial markets. Because normally, if there were no imperfections like that, then of course the world interest rate applies also domestically, right? At least in the long run. While this gamma introduces a wedge between the world and home interest rate. And this is very much motivated by some kind of I would say now rich empirical evidence about the link between the country risk premium and its international investment position. So this is what we take from the literature. So you essentially cannot borrow as much as possible from the outside world, because at some moment the interest rate you have to pay on that debt actually will increase and will make it actually not profitable for you to borrow anymore, right? And of course it works in both directions. So very briefly about the production side. So final goods can be either consumed or invested, and they consist of homemade and foreign components. We have a standard capital accumulation law of motion and a sort of standard production function that uses capital and labor. And importantly, because we want to have some role for the monetary policy in this model, actually this firms producing intermediate goods will face price stickiness that we model in a sort of standard way. So this is the Calvo type price stickiness. This is actually quite an important slide because it shows what the monetary policy does in this model. So the monetary policies might be constrained by the zero lower bound. So the gross interest rates cannot fall below 1. So net ones cannot be negative. Otherwise, we have like a sort of Taylor-like monetary policy rule. So the monetary policy responds to deviations of inflation from the target, from deviations of output growth, from its potential output growth. There is some interest rate smoothing, and there might be some monetary policy shocks. Now, also, actually, the level of the interest rates, just like in the standard Taylor rule, long-run level of the policy rate depends on the estimate of the natural rate of interest. Okay, the nominal one. Right? And actually, here we will have two assumptions. So we'll either assume that the central bank can observe the natural interest rate in real time. This will be like our baseline scenario. Or it will be, or the natural interest rates will be actually gradually learned. So the current estimate of the natural interest rate that the central bank uses in its monetary policy rule will be equal to the previous actually value of this, to its previous value, times some learning gain, so that actually, you know, if you see that you've made a mistake in the past, you update your current estimate with a certain proportion of this sort of error. So this is like a kind of standard specification from the learning literature. I think like the model is calibrated using some Eurostat data, Europop 2013 estimates of the demographic trends. So actually, this also applies to the figures I showed you just while motivating this work. Well, what else is interesting? We also, like, you know, whatever we can, we estimate outside of the model and take from the literature. And the speed of learning parameter, which is actually quite important one, is also like taken from the related literature. When like calibrating the stochastic structure of the economy, we, you know, the euro area economy is just like estimated outside of the model. Remember, we treat Poland as a small open economy, so whatever happens in the euro area is actually unrelated to what happens in Poland, right? As far as other shocks are concerned, we perform a moment matching exercise, and this like summarizes how well we are doing in that respect. And actually, we are doing extremely well for the nominal interest rate moments. I mean, standard deviations and autocorrelation, but this is sort of imposed. But also other moments, actually, I think are matched pretty well. So I guess like these stochastic simulations, the outcomes of which I will rely on, I think have quite a good backing in the empirical data. So I think I will skip the solution methods. So let me actually now move straight to the results. So actually I will show you a couple of things. Okay, I will show you the impact of demographic transition, which is essentially feeding these demographic trends that I showed you just right at the beginning of my presentation to simulate what happens in the euro area. And then, you know, simulate, given what happens in the euro area, what happens in Poland, right? Okay, so because, you know, what happens in the euro area affects also what happens in Poland. Then I show you some consequences for the monetary policy. So I will show you how the inflation rate looks like under either perfect observation of the natural interest rates or under gradual learning, and I will show you some ZLB risk estimates. And finally, and this will be the last thing, I will show you how actually foreign demography affects our model economy. So these are the charts for the euro area. I apologize for the scale for the real interest rates here. Actually, it's you have to like divide it by 1,000 to make a reasonable number. But just starting from the second row, you know, these hours worked and GDP are expressed per capita. Okay, so actually, you know, you have a decline in total hours worked because, you know, people live longer but work only like until the retirement age. So okay, so per capita hours worked decline. So this also means like a fall in per capita GDP, and exactly for the reasons I mentioned before, since people live longer, they have to accumulate assets for the time when they are retired. So actually this means that the assets to GDP ratio goes up, okay? For the euro area, which is a closed economy, this essentially means that people accumulate more physical capital, okay? Because there are no other significant assets that are not in fixed supply. And this translates into a drop in the real interest rate that is actually goes down if you take the starting point in the year 2000. So actually already a couple of years in the past, it starts from 1.2 to something like 0.2 in around 2030. So you have like this decline by 1 percentage point, quite spread over time, but quite a significant one, I would say. In Poland, the story is similar, but actually, given the more severe demographic trends, actually the decline in the real interest rate is much bigger. As I said, like it goes. At some point it reaches nearly 2 percentage points, and you also have like this decline in the GDP per capita. You have this increase in assets to GDP ratio, but since Poland is an open economy, then actually all these like extra savings can be also invested abroad. So you can see that you have quite a substantial drop in the foreign debt to GDP ratio. So you essentially export savings, and as I said, like this drop is quite substantial. So currently we're running at around 55% of foreign debt to GDP. If these demographic trends get realized according to our model, will be down to something like below 40%. So quite an important movement and quite an important thing to think about if you're at a central bank that is also concerned by the external imbalances. Now this slide is actually, I think, like quite important because it shows you the inflation rate as it evolves during this demographic transition in Poland under two assumptions about whether the central bank perceives this decline in the natural interest rate in real time or not. So if it does, then you should look at this black line, and then you see that the inflation is essentially constant at 2.5, which is like the current level of the inflation target in Poland. Okay, 2.5. Okay, sorry, I almost. Now, if actually instead you actually fail to notice, or essentially disregard the demographic trends while you're a central banker, so you actually learn only gradually about this decline in the natural interest rate, look what happens with inflation. Actually, you have like a negative bias in that sense that inflation is well below target, and it's not only like a couple of periods, it's quite a protracted actually process, and the scale of this bias is quite substantial, at some points reaching like 1 percentage point. So you can see that even though these demographic processes are slow moving, like over time, actually taking them into account while designing the policy, at least when it is governed by the Taylor-like rule, is actually quite important. Then the probability of hitting the zero lower bound, if you look at the beginning of this chart, and the black line is our baseline, it's actually pretty low, so it's something like 1% annually, so it's really not a big deal. Then if you take into account this demographic transition, but the central bank actually observes the fall in the natural rate of interest in real time, it gets larger, but I would say it's still like, well, maybe not to ignore, but manageable. But if you fail to actually account for these demographic trends in real time, then actually you end up with a probability that you cannot actually easily disregard. It can go up to as much as 15%. So for an economy like Poland, which has never actually experienced this kind of situation, it is something I think to a little bit worry about. And the final thing is like this impact of what happens abroad. So the black line actually replicates our baseline scenario. So I told you like this fall in the foreign debt to GDP ratio from like something like 55% nowadays to below 40%. Now, if actually the euro area didn't have any demographic transition, so that like the fertility rate and the mortality rate were constant in this region, you would essentially, you wouldn't see any like, no, sorry, I just wanted to start with this, with the other. So the gray line is actually what would happen if the euro area had exactly the same demography as in Poland. So the same fertility rate over time, the same increase or the same paths in the mortality rate. So then you wouldn't see actually any export in savings abroad, so the net foreign assets position would be constant. At the other extreme, you might be interested in a situation in which actually there is no demographic transition in the euro area, and this looks like a bit crazy picture, so it's more or less like a thought experiment. Then you could see that actually the net foreign assets position in Poland would actually turn from like a negative position to surpluses. But I'm not showing you that just for the sake of looking at the foreign debt to GDP ratio. It's just more about how it affects actually what happens with the real interest rate. And here actually the message is not so good, because actually, I mean, if the euro area had the demography like in Poland, well, the situation in Poland would be a little bit worse. So the decline in the natural interest rate or in the real interest rate would be somewhat bigger, but not much, right? But actually, even if there was no demographic transition in the euro area, so you wouldn't have this like export of downward pressure on the real interest rate, then still the real interest rates in Poland would actually record quite a significant decline. So the bottom line from all of that is actually, you know, even if you're an open economy with some access to financial markets, actually, because of these financial markets imperfections, it's not that you can really, disregard demographic implications on the natural rate of interest. So I'm essentially ready to conclude. Like most of these things I've already covered. So the impact of aging on the natural rate of interest rates is substantial in the euro area and even more in Poland. And importantly, even though these changes, like demographic changes, are glacial in that sense that they really move really slowly, then it's very important to account for the changes in the natural interest rate because of the changes in the demographic situation in real time. This is, of course, easier said than done, right? But it's because it's not an easy thing. But at least I think you at least should keep it in your head, because there are some chances that at least you will manage to avoid deflationary bias or also somewhat keep the ZLB risk under control. And finally, actually, even though the aging process might be important in what happens to the current account or the external positions of the economy, for the natural interest rates actually at home, it's there is some impact, but actually not so great. So actually, your own demographic developments, even if you're a small open economy, actually matter quite a lot for the evolution of the natural rate of interest. So yeah, that's it.
Thank you, Marcin. And as always, we have time for questions. Please, gentlemen in the third row. Could someone please give a microphone? Thank you.
Thank you for your presentation. Have you thought of including somehow migration into your model and controlling for its effects? Thank you.
Yeah, actually, it's actually a very important comment, right? Especially because of the place where we are and where I came from, right? So we've received quite a big migration inflows to Poland from Ukraine, but on the other hand, quite a lot of people from Poland moved to the Western Europe. So I think that on balance, we are. I wouldn't say we are even exactly, but these processes to some extent offset each other. But actually accounting for migration in this kind of models is not so easy. But I agree it would be important to have it, and of course, inward migration might alleviate these kind of processes, right? Quite especially if as you see in the data, the people migrating people are people in the working age, right? Not necessarily the retirees. So they clearly improve this old age dependency ratios and other things that lead to these developments that I studied here. Yeah.
We still have time for questions. the gentleman who also.
Thank you very much for your presentation. You related the aging of population to monetary policy and actually to economic growth. Today we have heard already that it's a problem of not sufficient aggregate demand for economic growth, but if we consider the aging population, it's like long period of living for people, it means that potentially it should stimulate the aggregate demand because they consume more. Unfortunately, we see that aging of population doesn't stimulate the aggregate demand. And you relate the aging population with debt and monetary policy. So do you think that why aging of population doesn't stimulate aggregate demand? And the second question is, what are the more strongest factors influence on aggregate demand rather than aging of population?
Mm-hmm. I'm not sure I got the second question, but let me maybe first respond to the first one. Well, yeah, sure, it's a general equilibrium model. So you have both supply and demand effects, and if you think about aggregate demand, you know, as I said, like with aging population, especially if people don't start actually working longer, okay, so you have like this increase for the supply of savings. So in that sense, like the propensity to save in this economy increases, right? So if this is what you had in mind by aggregate demand, right, effects, then demographic trends have like negative effects on aggregate demand. That's why, you know, if you fail to account that you have this deflationary pressure for inflation, that's why you have this increase in the savings rate, and that's why you export capital abroad. And I'm not sure I got the second question exactly, so could you? So you mean other processes that might affect economic, other than demography or something? Yeah, sure, right? So this is the model that deals only with with demographic processes. So that's why on the charts I showed you, you see the decline in GDP per capita, right? If you add to that technological progress, which is not there in the model because it's not the focus of this paper, you know, the outcome would be different, right? So actually, you know, there can be many other things that affect the outcomes I showed you, but I'm just focusing on the demography here.
We have time for 2 more questions.
Mm-hmm.
Thank you, Yuriy Gorodnichenko. I was wondering what will happen in your model if you endogenize fertility. For example, as agents accumulate more capital, capital becomes more abundant. It means interest rates go down, wages go up. But as wages go up, the opportunity cost of having children increases even further. And so you can have this vicious cycle when you actually make transitions to very low interest rates very, very fast. That's one question. And second question, Ukraine has a slightly higher inflation target, 5%. And again, I think it also has a higher rate of population contraction. It seems like your study is suggesting that it's a good idea because Ukraine will have a bigger buffer before it hits a zero lower bound. Thank you.
Yeah, so surely it would be nice to endogenize the fertility. We haven't done it actually. I don't think it's like an easy way. There is an easy way to do that, but yeah, you're right. Like if you know, surely like the fertility rate depends on the economic situation. This is one of the reasons why it collapsed so sharply actually in Poland. This is at least what other research shows. That's why it collapsed so sharply during the crisis that we had after like during the transition from the command economy to the market economy. So I guess like yeah, I think that these projections for the fertility rate somewhat like take into account the fact that Poland is, or also the EU, is going to like you know, grow further in the future because of some technological progress, but it's purely exogenous. So I agree that this link would be nice to have, right? But I think that even so, yeah, okay, maybe let me stop my answer at this point. Now about the level of the inflation target. This is actually a fair point. So in Poland, we have like the inflation target that is slightly larger than in the Eurozone. It's not much, it's like a 0.5 percentage point, but still. And also we have like the higher natural rate of interest rate, probably because we are catching up economy, etc., right? And this is exactly the reason why Poland, at least nowadays, but who knows what will happen in the future if things materialize, as I showed you, is actually quite well protected from the zero lower bound. But more generally, if you know, one of the ways, and quite an easy or straightforward fix of this increase in the probability of the zero lower bound is just to increase the inflation target, right? So if Ukraine faces like larger demographic problems, right, than Poland, and it has actually higher inflation target, I think it's like a reasonable mix. Of course, you know, this is not costless, right? If you believe in monetary frictions or the cost of price dispersion, it might have its cost, but as we know, like once you hit the zero lower bound, actually things might become quite nasty, so you might really want to avoid this situation. So probably keeping the inflation target a little bit higher to somehow minimize this risk is probably a good idea.
We can afford one short question. If there are no questions, let's all thank Marcin. And thank you all for coming to our first policy session. Now let's have a short 15 to 20 minute break.